Okay, welcome to our first video lecture for consumer math. The note sheet that I'm going to be looking at and going over in this video is the very first one you have. It looks like this. It says Unit 1, Day 1 notes on it. The objectives for this video are to be able to calculate averages if you're given a bunch of numbers or values, to compare values that are given, see which one is greater or which one is smaller. Make sure that you can round to a given place value and also give in the place and value of any digit. Okay, first thing we're going to start off with then is place value review. This is something that you learned back in elementary school and you probably haven't thought about it since then. And it's kind of obvious, and you're going to be like, well, obviously this is true. But every time you write a number, where the number goes in terms of the whole number has meaning. So we have a little chart right here, and the chart is kind of centered, or it's important to know where the decimal point is in the chart. If there is a decimal point in a number, that's really important, because from that decimal point, you figure out what all of the places of all the different numbers and what they mean. These numbers are off center for some reason, so I'm gonna draw some arrows, and I hope you would too on your own sheet, so that you know which one goes with which. Okay, they're off center for some reason. So, starting from the decimal and working to the left are numbers that are bigger than 1. They're whole numbers, okay? The first place is the ones place, followed by, as you keep going to the left, the tens place, the hundreds place, the thousands place, 10,000s, 100,000s, millions, and we don't have a number in the 10 millions place. So our number right here, if you were to write this out normally, would be this. I'll just write it up here. 5,647, 210.392. So the 0 is in the ones place, the 1 is in the tens place, the 2 is in the hundreds place, 7 is in the thousands place, 4 is in the 10,000s place, 6 is in the 100,000s place, and 5 is in the millions place. To the right of the decimal, we have slightly different places. And you'll notice that they look kind of similar, but they all include TH at the end. And we also don't have a ones, corresponding ones place or a oneths place. From the right of the decimal, as you keep going right, we have tenths, hundredths, and thousandths. If we were to keep going, we'd have 10,000ths place, the 100,000ths place, the millionths place, and so on and so forth. So for this number right here, 3 is in the tenths place, 9 is in the hundredths place, and 2 is in the thousandths place. Okay? And again, what each of these numbers means is that where each digit is in the number is very significant. So for instance, this 1 that is in the tens place represents a 10. The 4 in the 10,000ths place represents a value of 40,000. And the idea is, if you were to add up all of these, what they represent, you would get this number. You would have 5 million plus 600,000 plus 40,000 plus 7,000 plus 200 plus 10 plus 0 plus 0.3 plus 0.9 or 0.09 plus 0.002. If you were to add up all of those, then you would get this number that we're given. So what we're going to do now is we're going to, a couple of times, identify the place of the underlying digit and then state the value of it. So it gets a little tricky sometimes. You have to remember that if there's not a decimal listed, then the decimal must be at the very end, and it's just not written. Okay? We would read this obviously as 4,389. It's implied that that decimal point is to the right of the 9. So if the decimal point is here, this is the ones place, this is the tens place, this is the hundreds place. This place is hundreds. And because it's in the hundreds place and there's a 3, the value is 300. And again, the idea with saying that the value is 300 is that you can do this for each of the places. This would be a 4 in the thousands place, so that's 4,000 plus 300 plus 80 plus 9. 4,000 plus 300 plus 80 plus 9 gives us 4,389. So that 3 really refers to 300 because it's in the hundreds place. We have another example, 293.903. Our decimal point is right here. The first place to the right of that is the tenths place. And we have a 9 in the tenths place, so that means that the value is 0.9. Or, another way to think of it is 9 tenths, 9 over 10. In this example, we have the decimal point here. That's the ones place, tens, hundreds, thousands, 10,000s. And since it's an 8 in the 10,000s place, 8 10,000s is 80,000. Place value is important when it comes to rounding, and very often in this class you'll be asked to round a certain amount, or round to a certain level or to a certain place. Remember that when you're rounding, if the number behind, or the number to the right, I should say, of the place you're trying to round to contains a 5 or larger number, that means you have to round up. If the number to the right of the place you're trying to round to contains a 4 or less, you keep it the same. So, let's see. We want to round to the nearest hundreds place. There's no decimal here, so that implies that it's at the end. So that's the ones place, the tens place, the hundreds place. I'm going to underline the hundreds place. Now we look to the right of that. We have a 3. The 3 means that since it's 4 or less, we have to keep the number we're rounding the same. So that means the 6 doesn't change. It doesn't mean the 3 doesn't change, okay? The 3 just tells us what happens to the 6. So the process here is figure out the place, okay? Underline it. Look just to the right of that. That number will make the number you underlined either round up or stay the same. In this case, it makes it stay the same. So rounding this, we get 5,600. Notice that the last number that's not a 0 is in the hundred spot. That's what it means. That's what we have to do here, okay? If we round to the nearest thousands, then what we have is, let's see, decimal point is implied right here. We have ones, tens, hundreds, thousands place, 9, and we look behind it at that 7. That 7 is larger than 5, so it's going to round this 9 up. But how's it going to round the 9 up? It's going to round it up to basically a 10, which means instead of writing 10 here, we're going to write 0, and we're going to increase this by 1. So this would round to 290,000. So that's a little tricky, okay? Because you might say, oh, it looks like you rounded to the nearest 10,000. Well, no. We still rounded to the nearest 1,000. It just so happened that the 1,000 that we rounded to is also a multiple of 10,000. So in this case, we rounded this one up. So I guess the trick doesn't really work with this one. You have to remember that, sorry, I lost my train of thought. You have to remember that if the number that you're possibly rounding up is a 9, you're going to have an extra 0 there. Round to the nearest 10,000ths. That's the 10th spot, 100th spot, 1,000th spot, 10,000th spot. We look behind it, we look to the right of it. That's a 4. That's going to mean that this number stays the same. So this number is just going to stay 327,432.8973. I guess the technical way to say this would be 327,432 and 8,973 10,000ths, but I'm fine if you just say 0.8973. Okay, so that's a little bit on place and rounding. Let's go to the back. Let's look at inequalities very quickly. We're going to just write down the signs as you might remember them. The less than sign looks like this. The greater than sign looks like this. The reason they look like that is because we read left to right. So if you have two numbers here and here, then you would read this as the first number is less than the second number. So you would have to have something that's less over here. So like 4 is less than 5. It always opens towards the bigger number. So even though this is less than, it opens towards the bigger number. And because the first number is smaller than the second number, we say that it's less than the other one. Same thing over here. The sign always opens towards the bigger number. So we could have like 6 is greater than 3 in this case. Because remember, we read left to right. The less than or equal to sign is the same, but with a line under it. So you could say maybe like 5 is less than or equal to 5, because they're equal. The greater than or equal to sign could be like this. Same thing. So again, that would be like, I don't know, 8 is greater than or equal to 2. It could be bigger than or equal to it, just can't be less than it. So looking here, we have 453 on one side, 4,848 on the other side. Very obviously this one's bigger, so we're going to open the sign this way. And so how you would read that is 453 is less than 4,848. Last thing I want to talk about is how to calculate an average. You've been doing this, again, all this stuff you've been doing for years, but we do have to go over it before just to make sure that everyone's on the same page. So it says whenever you try and take the average, or a fancy math word for that is the mean, you add all the numbers together, then divide by how many numbers there are. So when we add all these together, if we do 45 plus 33 plus 76, okay. Oh, just want to make sure you can see all that. Plus 86 plus 43 plus 80 plus 42 plus 100 plus 101 plus 56. You add all those together and then you divide by how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to divide all that by 10. Now, do this in 2 steps on your calculator. Add the numbers, 45 plus 33 plus 76 plus 86 plus 43 plus 80 plus 42 plus 100 plus 101 plus 56. You get 662. 662, that's not my answer though. I need to divide by how many numbers there are. There's 10 numbers. 662 divided by 10 is 66.2. And that is how to take an average. If there are only 3 numbers, you would divide by 3. If there's 27 numbers, you divide by 27. Okay? So that's some basic review. I'll be back with another video in a little bit.